Acid-base stoichiometry today. So, the number of quantitative proton transfer reactions can be determined by a pH curve, of course. So when you look at a pH curve, if it's got one proton transfer, if it's got one spike or jump, you know, we kind of know what that's going to look like. That's a monoprotic curve, of course. If we had two spikes or two drops, we're going to have a polyprotic one. This will give the ratio to compare the amounts of the reacting acid and base. So we'll talk about that. You'll see once we do these. So just be patient a little bit if you don't understand that part. Trust me, this won't be too bad at all. Only one proton can be transferred between a monoprotic acid and a monoprotic base. They always have a 1-to-1 ratio. Hey, let's even think about like a strong acid and the strongest base. That's a monoprotic curve, right? Hydrochloric acid, HCl, H3O plus ions, and hydroxide react together to give you water, right? That looks like that, and basically it's a 1-to-1 ratio, okay? So, oh, hey, how about that? That's our question. Let's do this. Calculate the acid's concentration. So we need to find the concentration of the nitric acid. So I want you guys to start right here, okay? We're doing stoichiometry. We need to come up with an equation, okay? We need to put the information in the right spot. It's kind of like what we were just doing. We're not looking for the equivalence point in this case because they actually tell us the equivalence point. It says the average volume required is 8.45 milliliters. So that would be your equivalence point in this case. So they're telling you that. What I want to know in this particular example is the acid's concentration. So I want you to write out an equation for this. You should be able to do this. Yes? Do it now, quickly. Lithium hydroxide. There you go. It's all done. Perfect. Dun-dun-dun. That was quick, eh? All right, there's the net reaction. All right, so now what do we have here? We got 19.2 milliliters of 0.216 hydrochloric acid. So that needs to go here. 0.192 liters is your 19.2 milliliters. 0.216 molar. Yes. And it says we're going to react this completely with 25 milliliters of the phosphate there, our weak base. Okay? So once again, we C and V, we can find N. N is 0.004172 moles. We're going to move that over to here. Now, with polyprotic ones, it's going to be that 2-to-1. Always. Always, always. So don't forget, this is a 2-to-1 ratio, so I need to divide by 2 there. Do not forget that. Obviously, you know, on the diploma, are they going to have twice as much there? Are they going to have that option where if you just move 0.004 over? Absolutely they will. Okay, if they didn't, I'd be disappointed. I'd be let down if they didn't have that there. This would be 0.002. 0.07 moles here, half as much, of course, because it's a 2-to-1. So N and V gives you C, which is 0.0829 molar. Okay? And that's what you would need to do for that one there. Okay? Questions, anyone? All right. So the questions you only get 3 questions today, and like I said, they're going to be identical to these ones here. So as long as you kind of follow along there, you should be good. This one here says the titration between oxalic acid and sodium hydroxide proceeds to the second endpoint. The titration evidence is shown below. So oxalic acid and that there, all right, and sodium hydroxide. So look, in this case here, these are already done for you, yes? Or, no, they're not. Okay, good. Don't forget, remember, this is back to, we haven't done this, well, no, yeah, we did this year. Sure we did, with the potassium purple stuff, potassium permanganate, yes? Remember? We tried to get that light pink color kind of thing. We had that purple stuff and reacted with some hydrogen peroxide. We did oxidation numbers with it. It was fun. You guys balanced some stuff using oxidation numbers. Same thing here. Okay, remember, this is your initial burette volume. This is your final. So we need to subtract those two to basically figure out how much we've used, yes? So let's go ahead and subtract these. You can do this now or you can do it later, it doesn't really matter. This here, I'm going to write them down here just so you can see them. This will be 14.2. This will be 12.8. This will be 12.7. This will be 13.1, 12.9, and 12.8. Oh yes, okay. Those are the volumes that we got from basically taking the final minus the initial, yes? All right. So we are going to have to use those, right? What do you do with those volumes? What do you remember? What do we got to do with them? We need to, what's the word? Yeah, and average them, yes? Yeah, add the ones up that we need to and average them, yes? Correct? What do they have to be within? 0.2, yes. So we need to add up the ones that are within 0.2 and average them. How many do I take? Just 3? As many as I can within 0.2, yes? So which ones are within, well, this one's out to lunch here, so we can't use that one. This one here, this one here, this one, and this one, yes? Are all within 0.2, correct? Okay. Those are all within 0.2, yes? Is 13.1 within 0.2 of the other ones? Not, well, only the 12.9, but it's not within the other ones, so I can't use it, right? They have to be within 0.2 of each other. In other words, this is too far off. Is 13.1 within 0.2 of 12.7 is the question, and it's not, so I can't use it, okay? And if you go with 12.9 and 13.1, well, then you only got 2 numbers. You need at least 3, right? At least 3. So 4, 5, 6, 10, 20, whatever, but those ones. Averaging those, what are you going to get here for average volume here? I'm going to write this down here. Average volume is what? 12.8? Yeah? And don't forget, obviously, that'll be in milliliters. It will tell you that here. It'll tell you that there. But obviously, you know, 12.8 milliliters in a burette makes sense. 12.8 liters in a burette, that's a lot. 12.8 liters is like 6 2-liter bottles, you know, of Coke kind of thing. That's a lot, all right? So probably going to be in milliliters, and you'll notice here, of course, same thing, titration at 10 milliliters of oxalic acid, et cetera, okay? So now we need to come up with an equation for this, right? So oxalic acid and sodium hydroxide. So let's see here. Oxalic acid, of course, is HOOCCOOH, and sodium hydroxide is the strongest base. All right. So first, reaction 1. This is going to be polyprotic, absolutely. It tells you that in the question because it says to reach the second endpoint. So proton donor, proton acceptor, you're going to get H2O and OOCCOOH minus, or vice versa, whatever, however you want to write that. Lost an H, right? Basically that H went to the OH minus to give you water. That's reaction 1. Reaction 2 now. You'll take some more. You'll take the OOCCOOH minus and react it with some more strong base from the burette, okay, to give you, once again, proton donor, proton acceptor, water, and OOCCOO2 minus. All right? We are going to add those 2 up to get your net reaction. Now, some of you guys are probably saying, geez, do I really need to write out both those equations? I guess if you kind of pick up on the pattern here, probably not, no. Okay, as long as you understand that it's, in this case, going to take you one of those and 2 hydroxides to give you, of course, in this case, 2 waters and OOCCOO2 minus. Okay? Remember, this is used up, right? Anything that I make there, I use up for every 1 mole of that. figuring out the concentration stuff here. Here we go. Titration at 10 milliliters of oxalic acid. So I'm going to put that in right here. Obviously, that would be in the bottom part. In this case, that would be at the bottom part. You wouldn't put 10 milliliters of acid in the burette. That doesn't make sense. So 10 milliliters on the bottom. Okay. And it says we also have 0.204 molar sodium hydroxide. So that's going to go there. Yes, and then we have the average volume that we need to use, and we decided it was what, 12.8? Is that right? So 12.8. That obviously needs to go here. It can't go here because I already put the 10 milliliters there. Secondly, remember, it always says this, right? Titration between oxalic to the endpoint. It says right here, titration at 10 milliliters of oxalic acid. When it says 10 milliliters of oxalic acid, that's in the bottom. What's in the top part has to be the sodium hydroxide. You did all those trials, there was 7 of them or something like that, and you found the average volume to be 12.8 of sodium hydroxide. All right? C and V gives me N here, which is 0.0026 moles. I'm going to move that over to there. 2 to 1, so 0.0013 moles. Dividing it by that there, final answer here would be 0.131 molar would be your final one answer. Okay? Yep. Yep. All right. Questions, anyone? I believe on the last page there you should have the questions I think already put on the last page for you. So, like I said, you only got about 3 questions there, and you should be able to get those done for tomorrow. We'll go over those. You should be starting to do some key booklet questions, so make sure you bring your key booklet tomorrow. We'll probably do a little bit of that, perhaps. We're going to go over, we'll go over these homework questions and anything else you need to before your test on Monday.